We have mapped Mars and walked on the moon, yet more than 80% of our own oceans remain a black mystery. As you fall past the last shards of sunlight, a creature flickers into view. Its body transparent, its organs aglow, defying everything we would call normal life. Here, a mile under our feet, science faces a paradox. The deeper we explore, the more alien and unsettling the creatures become. Why does Earth's ocean grow stranger with every meter down? Let us begin the descent. Below 200 meters, sunlight turns thin and blue, then fades almost completely. Here begins the twilight zone, a world where Earth's photosynthesis fails and plants disappear. The only food is marine snow, a slow, endless drift of dead plankton, fish scales, and waste from the surface. In this dim, hungry world, life faces a new challenge: how to survive without being seen, and how to spend as little energy as possible. Many creatures here, like the glass squid, have bodies so clear that muscles, stomach, and even the eyes seem to float in empty space. Transparency is not just a trick, it is a survival strategy. Pigment costs energy, and in a place where every calorie counts, being see-through is the cheapest defense. Predators searching from above or below often see nothing at all, just a faint outline if that. Some fish and jellies become so ghost-like that they are almost impossible to spot. Even under the strongest light, scientists can shine from a submersible. Movement too changes. Shapes grow long and thin. Fins shrink and motions slow to a crawl. The less you move, the less you show up, and the less you need to eat. In the twilight, the first hints of alien design appear. Not monsters, but bodies that quietly erase themselves from view. Yet even here, hiding is not always enough. As the last rays of sunlight vanish, some creatures begin to create their own light, not to be seen, but to disappear even further. Down here, light is more than just a memory. It is currency. 9 out of 10 creatures in the Twilight Zone produce their own glow. This is bioluminescence, living light made from chemical reactions inside the body. Some fish and squid create tiny spotlights to search for prey. Others use light as a cloak, not a beacon. The trick is called counter-illumination. By tuning the glow on their bellies to match the faint light trickling down from above, they erase their own shadows. To a predator lurking below, the outline vanishes against the blue haze, making the animal nearly invisible. But light is not just for hiding. Some jellies and shrimp flash like emergency signals to startle attackers or call for help. Others use it to lure meals straight to their mouths. The deep ocean's a silent battlefield of invisible signals and sudden bursts of color. Most of it happens in wavelengths our eyes cannot even see. Dr. Edith Witter, a pioneer in deep-sea exploration, built a camera system called Medusa to finally catch these displays in the wild. Instead of blinding white lights, her camera used darkness and a fake jellyfish that pulsed with blue light, mimicking a natural alarm. For the first time, scientists recorded undisturbed flashes and secret signals, including the first real footage of a giant squid responding to the lure. Witter's work showed that in the deep, light is not just for seeing, it is a language, a weapon, and a shield. As the twilight fades, the rules of survival change again. Down where sunlight never reaches, creatures begin to weaponize darkness itself. Past 1,000 meters, the ocean is absolute night. Here begins the midnight zone, a place where sunlight never reaches and the pressure is enough to crush unprotected metal. Life in this blackness arms itself with weapons the surface world can't imagine. The dragonfish hunts with a red bioluminescent searchlight. Its lower jaw glows with deep red light, invisible to almost every other animal. Only the dragonfish and a handful of its relatives have eyes tuned to see this wavelength. When it sweeps its red beam across the dark, prey are lit up like ghosts, unaware they have been spotted until it's too late. Other hunters and prey have evolved a different defense: ultra-black skin. Some deep-sea fish, like the Pacific black dragon and certain anglerfish, have skin that absorbs over 99.5% of all light. Even the brightest submersible beams vanish against their bodies. Under a camera, these fish seem to erase the very idea of a silhouette, turning into holes in the water. Dr. Bruce Robison at the Monterey Bay Aquarium Research Institute has described these creatures as living shadows, so perfectly camouflaged that their edges disappear into the darkness. Anatomy itself grows more alien. The anglerfish dangles a glowing lure in front of needle-like teeth, drawing in anything curious enough to investigate. but its most disturbing adaptation is how it mates. In the crushing dark, a male anglerfish fuses his body to a female, merging into her flesh until he is little more than a living appendage, providing sperm in exchange for food and blood. Many of these animals are so finely tuned to the deep that they cannot survive the journey to the surface. Their bodies collapse, or even dissolve the moment the pressure lifts. Down here, every feature, every organ, every pigment exists for a world where light is a weapon, and the rules of life are written in darkness. At 4,000 meters down, the ocean floor opens into the abyss, a desert vaster than any found on land. Here, the temperature hovers just above freezing, and never much warmer than 2 degrees Celsius. The water is black and still, stretching for thousands of kilometers with almost nothing to break the monotony but rare scattered mounds and the slow drift of marine snow. Food is so scarce that some animals may wait months between meals. In this emptiness, life follows a different pace. Metabolism slow to a crawl. Movements become measured, almost glacial. Some creatures may live for centuries, aging so slowly that a single lifetime can outlast the rise and fall of civilizations above. Even the colossal squid, with eyes as big as dinner plates, prowls these plains. The puzzle of deep-sea gigantism has drawn scientists for decades. One idea is that the cold, stable environment lets bodies grow slowly but steadily, stretching lifespans and allowing for massive size. Another theory suggests that being big is a defense. Large bodies are harder to eat and better at storing energy for the long fast between meals. But no single answer fits every giant here. The truth may be a blend of cold, pressure, and the simple fact that in a place where nothing changes quickly, slow and steady wins the race. Sylvia Earle, who has spent thousands of hours in deep water, once called the abyss a place where the ordinary rules of life no longer apply. Down here, time stretches, hunger is constant, and survival means adapting to a world that feels almost timeless. Each giant is a monument to patience, endurance, and the strange mathematics of scarcity. In the abyss, emptiness is the rule. But when something enormous dies and falls from above, that emptiness is shattered, and a new story begins. When a whale dies and his body begins to sink, the empty plains of the abyss are transformed. What was once a lifeless stretch of mud becomes the site of a sudden, violent feast. The fall of a whale, sometimes called a whale fall, delivers more food in a single moment than most deep-sea creatures will see in a lifetime. As the carcass drifts down, scavengers gather from miles around, drawn by chemical signals invisible to us. First come the sharks and hagfish, tearing through soft tissue in a matter of days. Their feeding frenzy strips away muscle, skin, and organs, leaving only bone and a slick of fat. But the story doesn't end when the flesh is gone. The next wave is stranger. Armies of tiny invertebrates, crabs, and worms descend on the remains. Some, like the Osedax worm, have no mouth or stomach. Instead, they bore directly into the bone, secreting acid and growing root-like tendrils that dissolve the marrow. Symbiotic bacteria inside their bodies finish the job, breaking down fats and proteins that would otherwise be locked away forever. Over weeks and months, the skeleton becomes a miniature city, riddled with tunnels, covered in mats of bacteria, and crawling with life. A single whale fall can support hundreds of species and thousands of individuals. Some of these communities last for decades, shifting as each layer of the carcass is consumed. Early visitors are replaced by specialists, which in turn make way for even stranger organisms adapted to scavenge the final scraps. Scientists first discovered these oases in the late 1980s, after remotely operated vehicles stumbled on clusters of scavengers around a sunken whale in the Santa Catalina Basin. In less than 2 years, the entire skeleton had been reduced to a ghostly outline, proof of just how efficient and relentless the deep-sea ecosystem can be. Down here, death is never wasted. Every whale fall is a rare, dramatic windfall, a boom in a world built on famine. Without these sudden gifts from above, many deep-sea creatures would never survive the long, barren stretches between meals. If you're still here, you're probably as obsessed with this weird deep-sea world as I am. Hit subscribe so we can keep diving deeper. Below the abyss, the seafloor drops into narrow trenches that cut deeper than Mount Everest is tall. At these depths, 6 to 11 kilometers down, the pressure climbs past 1,000 times what we feel at sea level. A human body would be flattened in an instant. Yet here, life has found a way to persist. The hadal zone is ruled by creatures like the snailfish, whose bodies are so soft and gelatinous, they would collapse anywhere else. Their cells are packed with unique molecules called piezolites, which prevent proteins from folding the wrong way under crushing force. Instead of strong bones and thick skin, snailfish rely on flexibility, bending with the pressure rather than resisting it. Even here in the planet's deepest cracks, the surface world leaves its mark. Dr. Alan Jameson, a trench explorer, discovered plastic fibers inside amphipods sampled from the Mariana and Kermadec trenches. These tiny scavengers, living more than 10 kilometers below the surface, carry synthetic threads in their guts, proof that human waste has reached places sunlight never will. Jameson's findings shattered the idea that the trenches are pristine. He wrote that there is nowhere left untouched after his team's discovery. Down in these trenches, every heartbeat, every twitch of a fin is a triumph over physics. Life here doesn't battle the pressure, it adapts, shaping itself to fit the impossible. But survival in the trenches isn't just about withstanding force. In some places, it's about finding energy where sunlight and even marine snow cannot reach. Near volcanic cracks in the seafloor, the ocean transforms again, this time into a world powered by pure chemistry. Hydrothermal vents spew water heated to 350 degrees Celsius, loaded with hydrogen sulfide and heavy metals. Instead of sunlight, life runs on the energy locked inside these toxic plumes. Giant tube worms, Riftia pachyptila, form dense fields around the vents. They have no mouths, no guts, and no eyes. Instead, each worm houses a living factory of bacteria inside a special organ called the trophosome. These bacteria use hydrogen sulfide as fuel, breaking it down to make food from carbon dioxide, a process called chemosynthesis. The worm's bright red plume acts as a gill, pulling in the raw chemicals that keep this partnership alive. The result? Animals that thrive in darkness, built entirely on the energy of the Earth's interior. Other vent dwellers, like the yeti crab Kiwa hirsuta, farm bacteria right on their hairy claws. By waving their arms in vent fluid, they encourage the bacteria to grow, then scrape them off for food. Every creature here, from vent clams to blind shrimp, depends on these chemical partnerships. Dr. Richard Lutz, who has spent decades exploring these vents, calls them cities of life blooming from poison. Nothing here relies on the sun. These oases prove that life doesn't need light, only energy and the right chemistry. That is why scientists study vents as blueprints for possible life on Europa. If entire ecosystems can rise from volcanic gases in Earth's abyss, maybe similar worlds wait hidden beneath alien oceans. Less than 5% of the global ocean has been explored by humans. The rest, over 80%, remains unmapped, unseen, and largely unknown. Most of what we picture as the deep sea comes from tiny circles of light cast by submersibles or brief flashes caught on remote cameras. Beyond those beams, the darkness stretches for thousands of miles, hiding landscapes and life forms we can only guess at. Technology falters quickly in these conditions. Cameras crack under pressure, electronics corrode, and even the toughest robots can only last so long before being forced back to the surface. Each expedition is a gamble. A few hours of footage, a handful of samples, sometimes nothing but static and black water. What we do find often feels like a message from another planet. Creatures with shapes and colors no one predicted. Entire ecosystems built on chemical reactions instead of sunlight. Some species have been seen only once, never caught again. Others defy explanation. Their bodies so delicate they dissolve before scientists can study them. The deeper we look, the more we realize how little we understand. Every dive adds to the list of questions. Why do so many animals glow? How did such bizarre forms evolve? What is waiting in the vast, silent spaces our lights have never reached? The unknown is not just a gap in our knowledge, it is an ocean in itself, reminding us that the world beneath our feet is still mostly a mystery. Every year, new species emerge from depths we barely understand, while plastic and climate change reach even the ocean's most remote trenches. Our discoveries keep outpacing our explanations, reminding us that Earth's strangest life isn't just out of sight, it's still rewriting the rules. If this is just the first 5%, the real unknown is what is still watching from the dark.